I've noticed a few people struggled with this question, so I want to take a few minutes to go over it. Now, we're asked to take this equation, we're supposed to solve these questions without graphing. So my first part here for A, I have to write an equation for a line that is parallel to the equation, and it passes through these points. Now, what I know about parallel lines have the same slope. Now, based on what I'm looking at right here, a lot of people just jumped right in based on this. But however, the problem is this is not in slope-intercept form. I don't know my slope yet. I have to figure out what that's going to be. Right now, it's closer to standard form. Now remember, slope-intercept form is y equals mx plus b. I have to have something that looks like this. So here's what I saw a number of people do. Great start. They add 5x to each side. They ended up with negative 10y equals 5x plus 40, and they thought they were done. Here's the problem. This is not y equals mx plus b. You'll notice there's nothing in front of y here. There's no coefficient, whereas over here, we still have a coefficient. So we are not out of the woods yet. We got to get rid of that coefficient. How I get the y alone? I'm going to divide each side by negative 10. And notice I'm doing that to everything. Do it to each term. Now I'm close. I get y equals negative 5/10 x plus 40 over negative 10. And I can simplify this. Now I'm just going to shrink this down first. Here we go. Negative 5 over 10x. That gives me y equals negative 1/2 x. And then 40 divided by negative 10 gives me negative 4. So now I have the original equation they gave us. This is in slope-intercept form now. Now I can work with this. So now since I know parallel lines have the same slope, I can focus on the slope. The slope I have here is negative 1/2. Now, you'll notice that negative 4 is our y-intercept. However, for parallel lines, they have different y-intercepts. I cannot use this. However, I do have a piece of information here. The coordinates they gave me, negative 20 and positive 30. Negative 20 will be my x value, or my input. 30 will be my y. What I can now do is using the form y equals mx plus b. For my new equation, I know what my slope is going to be. It's going to be the same slope. I know what y is going to be. It's going to be 30. I know what x is going to be. It's going to be negative 20. And I'm going to be solving for my new y-intercept for this line that's going to be parallel. So now it's just, doing some basic algebra. 30 equals negative 1/2 times negative 20 will give me positive 10 plus b. Subtract 10 from each side, and I find out the y-intercept for my new line is going to be 20. So now what can I do? I can write the equation for the line that is parallel to our given equation. Whoops. So I can write a line that is parallel to our given equation here, the one at the very beginning. I have y equals negative 1/2 x plus 20. If I graph this, it's going to be perfectly parallel to this original equation here. Now for the second part, I have to do a line that is perpendicular to the equation that passes through. All right, so I'm going to take this down here. I'm going to need it again. I used it up here. It's the same thing. It's in slope-intercept form. Now what I know about lines that are perpendicular, their slopes are opposite reciprocals. So I set my new equation as y equals mx plus b. My new slope, since it's the opposite reciprocal of negative 1/2, is going to be positive 2. Now I don't know my y-intercept. The 30 they give me here is not a y-intercept. It's just a coordinate. So I can't just plug in 30. What I can do is I can plug in 30 for my y and negative 20 for my x. And now allow me to solve for b. Negative 20 times 2 gives me negative 40 plus b. 30 equals. I can add 40 to each side. And I get 70 equals b. And I'm just about done. I just have to rewrite my equation now. So the equation for a line that's perpendicular to our original equation and passes through negative 20, 30 is y equals positive 2x plus 70. You can see why we use algebra for this, because if you're looking at these equations here, my final answers, I would not want to graph 2x plus 70. Negative 1/2 x plus 20, a little bit easier, but that's why we use algebra, especially when we have points like negative 20 and positive 30. We don't have to draw these huge graphs. We can just figure it out using basic algebra. Hopefully this helps you with example 9.